Hello everyone. In this video, we will explain the concept of wavy curve method. It is very important in calculus how to find out the interval of a real number x when a given expression is negative or positive, or given expression is greater than or equal to 0 or less than or equal to 0. So this wavy curve method will play a very important role in understanding of quadratic expressions or functions or applications of derivatives or integration, wherever it comes. This is a very important topic. So you please follow this topic carefully, and followed by I'll solve a few questions. You try to practice them. Before I explain what is that wavy curve method, so let me explain this method through a simple example. Here, for what values of x belongs to R, real numbers, that expression 2x plus 3 is negative. So in the previous video, I have explained that how to solve linear inequations. So here we want that for what values of x, that 2x plus 3 will be negative. So here we want that 2x plus 3 is negative. This implies we want to find out all values of x for which this expression is negative. So we will write this as 2x less than minus 3. Sending plus 3 right hand side implies dividing by 2, x coefficient 2. Anyway, we are dividing by positive quantity. So given inequality will remain same. Less than will remain less than. So here we got x less than minus 3 by 2. So if you take quantities or any real number less than minus 3 by 2, then 2x plus 3 will be negative. So this implies in interval form, we can write x belongs to minus infinity to minus 3 by 2. This is open interval. So first example is quite simple. So without using any knowledge, simply we can tell that for what values of x, 2x plus 3 is negative. Let us consider another example. For what values of x, the expression 5x minus 3 is positive. Now the expression we want positive. So here that 5x minus 3 we want greater than 0. So this implies sending 3 that side, 5x greater than 3. Now divide by 5. So you will get x greater than 3 by 5. So x takes values more than 3 by 5. If x takes values more than 3 by 5, then the expression 5x minus 3 is positive. So in interval form, we write x belongs to open interval 3 by 5 to infinity. So in other way, we can say how to solve simple linear equations. So solving simple linear equations is very easy to understand. But here another question is there, that for what values of x belongs to R, the expression x minus 1 into x plus 2 is negative. We want this. So here I will explain that how to find values of x belongs to R for which the given expression is negative. So here that x minus 1 into x plus 2, we want that this expression is negative. Well, see, this is the product of two linear factors. This is the product of two linear factors. So the first factor is 0. This is 0. When x equal to 1. The second factor is 0 when x equal to minus 2. Well, now let us plot these numbers on real line. So plot 1 and minus 2 on a real line. So this is the real line. Well, so plot these real numbers where that each linear expression is 0. So here minus 2 and here 1. Okay. Now see, left hand is minus infinity, right hand is plus infinity. You take any number more than 1. You take any number right side of 1. Okay. So I'll take a number sample 2. You take any number more than 2. Right. So substitute some number greater than 1. Substitute x equal to 2, which is greater than 1 in given inequality. Given inequality. So we get, see here substituting x equal to 2, that 2 minus 1 is 1 into 2 plus 2 is 4. We want only sign, whether positive or negative. See, this is clearly greater than 0. So if you substitute any number more than 1, this product is positive. So you keep positive sign above the real line. You keep positive sign above the real line. Now, you take any number between minus 2 and 1. Let us take 0. Between minus 2 and 1, let us take 0. So substitute x equal to 0, right? Which belongs to minus 2 and 1. In given inequality, we get, if you substitute x equal to 0, you will get minus 1 into 2, which becomes negative. So in this way, if you substitute any number between minus 2 and 1, the given expression is negative. So keep the negative sign below the real line. Below the real line. Now finally, you have to take any number less than minus 2. Substitute x equal to, I will take minus 3, which is less than minus 2 in the given inequality. Right? In the given, not inequality, of course, in the given expression. In the given expression. Well, so we get here, substitute x equal to minus 3, minus 4 into minus 1, which is greater than 0. Here we want that expression is negative. So here this expression is positive for x less than minus 2. So keep the positive sign here. So if you substitute any real number less than minus 2 or greater than 1. Less than minus 2 or greater than 1, that expression is positive. So here I'm writing for x less than minus 2 or x greater than 1, we have that x minus 1 into x plus 2 is positive. This expression is positive. Similarly, for x lies between minus 2 to 1, if x lies between minus 2 to 1, that expression x minus 1 into x plus 2 is negative. This product is negative when you take a real number between minus 2 to 1. So we got the answer, right? So therefore, the given expression is negative if x lies between minus 2 to 1. This process you can apply for any kind of expression, whether it is a rational expression or simply a product of several linear factors. Product of several linear factors. You see that each factor is 0 at what values of x, plot on real line. After that, you substitute any number greater than the rightmost. Okay, I'll take another example. Here is another example. Solve x into x square minus 1 less than or equal to 0. The meaning of this statement is, for what real values of x, the expression x into x square minus 1 is non-positive, which means less than or equal to 0. So here is the solution. Without using wavy curve actual method, we can find the intervals of x for which this expression is less than or equal to 0. So just rewrite the given expression as x into x plus 1 into x minus 1 less than or equal to 0. We want that this expression less than or equal to 0. So here, this is 0. This is 0 when x equal to 0. And this is 0 when x equal to minus 1. You have to see that each factor is 0 at what value of x? X equal to 1. So here we have three values. Means the given product is 0 at x equal to 0 or at x equal to minus 1 or at x equal to 1. So let us plot these values on a real line. Well, so here I am keeping minus 1, here 0, here 1. I'll apply the same procedure which I explained in the previous example. So you see, the real line is divided into 1, 2, 3, 4 parts. The real line is divided into 4 parts. So now, substitute any number more than 1. Substitute any number more than 1. So here I am writing substitute that x equal to, you take some number to easy number that is more than 1 in given expression. Okay, we get substitute x equal to 2 here. 2 into 3 into 1. It is positive. We want only sign, whether it is positive or negative. So the expression is positive when you take x greater than 1, so keep the positive sign above the real line. Above the real line. Now, we have to substitute some number between 0 and 1. Between 0 and 1, you have to substitute some number. Let us take x equal to some 1 by 2, which belongs to 0 to 1, which means that you have to substitute one number from each interval. Well, substituting x equal to 1 by 2 in given expression, we get 1 by 2 into 3 by 2. Don't take unnecessarily complicated number. Into minus 1 by 2. So this product is negative. So this product is negative means if you take any number between 0 and 1, you will get negative sign. So keep that negative sign below the real line. Now, substitute x equal to any number between minus 1 and 0. Any number between minus 1 and 0. So I will take same as in previous one. Differs in sign only. Minus 1 by 2. It belongs to minus 1 and 0. So substitute x equal to minus 1 by 2 in the given expression. You will get minus 1 by 2, 1 by 2 into here minus 3 by 2. So here negative into negative is positive. So this expression is positive. So therefore, here you keep the positive sign between minus 1 and 0. Finally, it won't take much time also actually to find out the intervals. Now you substitute any number less than minus 1. Any number less than minus 1. So you take that x equal to minus 2, which is less than minus 1 in the given expression. Well, now you see minus 2 into minus 1 into minus 3. Obviously, the product of 3 negative real numbers is negative. So we got that for any x less than minus 1, the given expression is negative. So keep the negative sign here. Now we want that expression is less than or equal to 0. Well, so we want that expression is less than or equal to 0. So x into x square minus 1 is less than or equal to 0 for, you see, wherever negative sign is there, you have to take that interval. Negative sign is there for less than minus 1. For x less than or equal to minus 1. Here I am taking equal to also because we want that expression is 0. Right? Or x equal to 0, only x equal to 0. Or we want that x belongs to 0 to 1. X belongs to 0 to 1. So I'll write 0 to 1. Well, so almost all we are done now. We got the interval. So therefore, this is nothing but, this implies that x belongs to minus infinity to minus 1 closed union closed 0 comma 1. Okay, you must check that this expression is 0 when x equal to 0 or plus or minus 1. These all three numbers must be included in the interval. So here minus 1 is included, 0 is included, 1 is also included. If any number is missing at which that expression is 0, that you have to add separately. So x into x square minus 1. Suppose we want to ask that it is greater than 0. For very simple, rest of the interval you have to write it. Rest of the interval. Here, this interval is taken for negative less than or equal to 0. So rest of the interval is nothing but for x belongs to -1 to 0, union 1 to infinity. We want that expression is greater than 0. You can see here. So expression is positive between -1 and 0, and it is more than 1. More than 1. Either this side or positive between -1 and 0. So to solve these kind of expressions, you can apply this technique. Well, so I'll explain another concept using the same thing so that later on, now I will give that actual wavy curve method. So here is another question, that solve x plus 2 whole cube into x square into x minus 1 whole power 5 greater than or equal to 0. Okay. So here you see little complicated example I have taken, but still it is very simple. So first of all, you see that this expression is 0, that x plus 2 is 0 when x equal to -2. And this expression is 0 when x equal to 0. And this factor is 0 when x equal to 1. So primary step is over. Now you have to plot these numbers on a real line. Plot these numbers on a real line. Okay. So we have to plot -2. This is -2. Of course, this is 0 and this is 1. So again, that real number is divided into 4 parts. Well, so we'll apply the same method. You substitute any number more than 1. Right? So x equal to, you substitute 2. So you will get here, you see, given expression is 2 plus 2, 4 cube. You need not to evaluate the actual value. We just see whether it is positive or negative. So 2 square into 1 to the power of 5. So this is positive. So here you keep that positive sign for more than 1. For x equal to, you take any number between 0 and 1. Let us take 1 by 2. Well, substitute here 1 by 2 in the given expression. 5 by 2 whole cube. Once again, I am telling, we do not bother about the value of the expression. We bother about only sign of the expression. Into here 1 by 2, 1 by 2 square into -1 by 2 whole to the power of 5. So first one is positive, second one is positive, third one is negative. So this expression is negative. So if you take any number between 0 and 1, it becomes negative. Well, now substitute any number between -2 and 0. Okay, so x equal to, let us take -1. So the given expression is 1 cube -1 whole square, nothing but 1. This is -2 whole to the power of 5. So clearly, first one is positive, second one is positive, third one is negative. So this expression is negative. So here we got a negative sign. So this is quite different from previous 2 examples. Here the sign to the right of 0 and to the left of 0 remains same. Here minus, here minus. Now we substitute Any number less than -2. You take x equal to, you take -3. Substitute here, you will get -1 whole cube into 9 into -4 whole to the power of 5. Okay. So here this is negative. -4 whole to the power of 5 is also negative. Negative of negative positive. So this is greater than 0. So here we got a positive sign for any number less than x less than -2. So almost all we are done. But what we learn in this, okay, we'll write this. What is the answer for this? Okay, so we want greater than or equal to 0. So greater than or equal to 0 means you have to search for positive sign. You have to search for positive sign. So here answer is that positive sign is there for less than -2 and greater than 1, right? So x less than or equal to -2, because we want that expression is also 0, or for x greater than or equal to 1, or we miss the 0, x equal to 0. So this is the answer. So therefore x plus 2 whole cube into x square into x minus 1 whole to the power of 5 is greater than or equal to 0 for x belongs to, see, minus infinity to -2. This is first interval less than or equal to -2. Union set 0, only single element is left alone. Union 1 to infinity. Now you will get a question or a doubt. Sir, if the given expression is very large, then it is very difficult to substitute the number between in each interval. So now I'm going to give the technique, but the observation what we done here, you see, we are plotting all the real numbers at which the given expression is 0, right? And here the x coefficient in each expression is positive. The x coefficient in each expression is positive. Okay. So what is the procedure? Well, here you see, this is power is odd number. Power is odd number. So you keep always plus sign rightmost. You keep always plus sign rightmost. So keep positive sign. Now, corresponding to this 1, right? It is the root of multiplicity 5. So this is odd. When the power is odd, you just change the sign. So plus to minus sign is changed. When the power is odd, right? When the power of a factor is odd, then sign will get changed. Now coming here, 0, right? It is x square. So the root of multiplicity 2 means the root is repeated 2 times. So this is even. This power is even. Then sign will not get changed. The sign will remain same. Whatever right side of that particular number is there, that will same will come to the left of 0. So same sign, negative sign came. Now here you see, this power is odd. This power is odd. So the sign will be changed from negative to positive. There ends the math. So the sign will be changed when the power of a linear expression is odd. The sign will remain same when the power of a linear expression is even. So I'll write an example so that you can understand now. Here is another example. Now We do not substitute any real number. Now you see. So this expression is 0 when x equal to minus 3 by 2. Right? So minus 3 by 2 means here you write minus 3 by 2. And this expression is 0 when it is minus 1. And this expression is 0 when x equal to 0. And 3x minus 1 whole square is 0 when x equal to 1 by 3. This is when x equal to, this is 0 when x equal to 3 by 2. Okay. Now observe. You keep always rightmost side is positive, provided x coefficient in each factor is positive. Okay. So this is 3 by 2. It is corresponding to 2x minus 3 whole cube. This is corresponding to 2x minus 3 whole cube. Right? So here this power is odd. This power is odd. So you have to change the sign. Okay? From plus to minus sign. Sign is changed. Now you see the 1 by 3. Next number is 1 by 3. So this is corresponding to 3x minus 1 whole square. So here this power is even power. So therefore, sign will not get changed. The sign will remain same. So here negative sign is there. So you have to keep negative sign to the left of 1 by 3. Next coming to 0. This is 1, 2, third one, 0. Here the power is odd. Corresponding to this, that x power 1, it is odd. Okay. Here this is even power. So sign will not get changed. Here odd power is there. So sign will be changed from negative to positive sign. Right? Sign will be changed. If it is right side, if it is positive, left side it will be negative. If right side is negative, then left side will be positive. Now corresponding to minus 1. Corresponding to minus 1. It is x plus 1 power 4. So here this is even power. This is even power. So when even power comes, there is no change in the sign. So you have to maintain the same sign. To the left of minus 1, to the right of minus 1. Now finally, this is x plus 3 by 2 whole to the power of 5. Whole to the power of 5. Okay. So here this power is odd. This power is odd. So when power is odd, you have to change the sign. So sign is changed from plus to minus. There ends the matter. Now why do we call this is a wavy curve method? Only just for beautification, we draw a wavy curve like this. When it is negative, you start from negative like this, like this, like this. So this is a wavy curve method. We draw like a wave. So that's why it is called a wavy curve method. Now we want that expression is greater than or equal to 0, right? So the expression, we want that given expression is greater than or equal to 0. So therefore this implies you find wherever positive is there. So positive sign is there between minus 3 by 2 to 0. So x belongs to minus 3 by 2 to 0. Well, union, again 3 by 2 to infinity. 3 by 2 to infinity. Remember, here we want that expression is greater than or equal to 0. So the expression is 0 at minus 3 by 2, minus 1, 0, 1 by 3, 3 by 2. But 1 by 3 is missing. So you have to take that union of set of 1 by 3. Because we want that expression is negative. So till now, I have discussed the examples in which there is no denominator. There is no denominator. I'll explain that example also. So here I have taken a rational expression. That rational expression here you see, for what values of x this expression is less than or equal to 0. Well, here numerator equal to 0 when x equal to minus 3, 0 and 1 when each factor is 0. Denominator equal to 0 when x equal to minus 2 comma plus 2. Okay, so these are known as either roots or zeros. Roots or zeros when numerator is 0, and these are known as poles. When denominator is 0, these are known as poles. Now you have to plot all these numbers on this line. So come here. This is minus 3 and minus 2. Well, this is 0, 1 and 2. So here the coefficient of x in each factor is positive. If it is negative, you multiply by negative sign. If it is negative, you multiply by negative sign in order to avoid the confusion. So keep the positive sign in the rightmost. Keep the positive sign in the rightmost. Always. Okay. So now here we have a 2. This is corresponding to this one, x minus 2 power 4. So this is an even number. I told you that when even number comes, there is no sign change. So you have to put the same sign, positive. Well, now coming to 1, right? 1 is here. This is a root of multiplicity is 2. This is even. So there is no sign change. When even power comes, no sign change. Now coming to 0. Here this power is odd. So there will be a sign change. This is negative. Now corresponding to minus 2. Corresponding to minus 2. Which means that x plus 2 whole cube. This power is odd. So there will be a sign change from negative to positive. Well, now coming to minus 3. So here this is power odd. So there will be a sign change. Over. So now let us draw a wavy curve. Okay, so negative below the real line, negative sign will be there. So you draw a wavy curve like this. When you solve the questions, in fact, you need not to draw this kind of curves unnecessarily. Time will be wasted. It is only for a beautification. Okay, just to understand a very clear. So now we want that expression is less than or equal to 0, right? So what is the answer now? You see, where you can find the positive signs, you see, 0 to infinity. This is minus. Remember, here denominator is 0 when x equal to minus 2 and plus 2. These are the poles. So these numbers will always be excluded in the interval. will always be excluded in the interval. They will be never included in the interval because the given expression is undefined when denominator equal to 0. So the numbers at which denominator equal to 0 will always be excluded in the interval. So now the answer is x belongs to here this 2 must be excluded. So what I will do, I will write from 0 to 2. 0 to 2 open. Union 2 to infinity. Well, here another positive sign is there. So union minus 3 to minus 2. So here minus 3 is closed. We want that expression also 0 and minus 2 open. So in this way you can find the intervals. So here is the rule for wavy curve method. Actually whatever we need that I explained it through the examples. So this is for the namesake only. Maybe some students may not understand. If I start with directly by symbols, etc. So here you see. So this is the given expression, right? One numerator is there and denominator is there. All the powers K1, K2, K3 in denominator R1, R2, R3 are all natural numbers. Remember, they are natural numbers. And B1, B2, B3, A1, A2, A3 are all real numbers in each factor, right? Then to solve the inequality, g of x greater than 0, g of x less than 0, g of x greater than or equal to 0, g of x less than or equal to 0, we use the following steps, right? So what are the steps? So far what I have explained that I am just keeping here. So first point number 1 is points where numerator becomes 0 are called zeros or roots of the function, and where denominator becomes 0 are known as poles of the function. This is the step 1. So what we have to do now, first we find the zeros and poles of the given function, right? Now then second point is this is the second point. We mark all the zeros, right? Put dark dot on real line, right? Because at those points function is defined. And all poles put a small circle on real line, because at those points that function or given expression is not defined on a real line. And put a vertical bar there dividing the real line in many intervals, as we did in the examples. Third point, keep the sign, right? Keep the sign expression in the rightmost interval, same as that of leading coefficient. Means if leading coefficient means, suppose for example x power 10 is there. If the coefficient of x power 10 is positive, right, keep rightmost side positive. If coefficient of x power 10 is negative, keep the rightmost is negative. So in order to remove this confusion, you always try to maintain that coefficient of x in each factor is positive, and keep always positive sign in the rightmost of the given real line. Keep always positive sign, right? So now moving towards left, right? Change the sign of expression across the root with multiplicity It means that the power of each factor, involved in the expression, add and retain the same expression across the root with multiplicity even. So if the power is even, sign will not be changed. Maintain the same sign. If power is odd, then you have to change the sign. After that, you have to write the interval. Well, so in the next session, I'll solve a few examples based on this wavy curve method. Thank you all. Watch the video again and again and share. This is very, very important one. So I'll explain in the next video with so many examples. Thank you.